Hey everybody, my name is Ben Meacham. I'm a high school chemistry teacher in Minnesota, and I've been a member of AMTA since 2012. Last month I created a video basically giving an overview of the Claim Evidence Reasoning Framework, otherwise known as CER. This month I wanted to create a video basically providing other educators with a way of how to implement and scaffold the CER framework throughout your class, regardless of whether it's chemistry, biology, physics, or any realm of science. Now, how do we actually integrate a claim evidence reasoning framework into our classrooms? Well, one of the most common and one of the most highly encouraged ways that I would suggest is to throw them into your labs. Whatever lab you're doing, you're going to obviously have some kind of conclusion from that lab. And instead of just asking them what they can conclude, ask them, what is their claim? What's your evidence? What have you gathered? What have you noticed that is even supporting that claim? And then finally, the reasoning. What's the underlying truth? What's the underlying science principles that are guiding how this evidence supports this claim? And then have students share these ideas with each other. Oftentimes, it really helps, as many modelers know, for students to actually engage in the process of openly communicating their ideas on their whiteboards. Another choice that you can at least navigate is the use of strong versus weak argument cards. Now, I put these up simply because they're actually sold as a product from the argument-driven inquiry store, which I'm not promoting necessarily, but I just wanted to use as a template for how these can be effective. And these cards can be easily made by you as well. The function of these cards is they contain effectively conclusions in kind of a CER format of the same lab, but some of the cards contain weak arguments, some of them contain strong arguments, and then some of them are kind of somewhere in between. And I like giving these to students because it's just as important for students to see a weak argument as it is a strong argument. And so I give these to students and I ask them, like, what do you think? Right? And oftentimes, just like us, you can almost just tell when you see a strong argument. But we get into the details. You know, what do you notice is better about this thing that you're calling a strong argument compared to the thing that you're calling a weak argument? And oftentimes this helps kind of shed light for students as to, like, oh, this is what you mean by reasoning. And so this is one thing I really like to do early on. Another thing that I like to do is just increase exposure. And so if we're having a quiz, I might take something like a traditional question that I might ask about the relationship between temperature and the rate of a chemical reaction. And instead of just asking them to give me a brief description of the relationship between those two things, I might give them just some sample data, and from that data ask them to come up with a claim, evidence, and reasoning. Instead, it's getting them to also practice this idea of what claim can I generate from this evidence, from this data that's in front of me, and what is the underlying reasoning that's actually guiding why this science explanation is true. In addition to that, I also like incorporating it into exams. And again, this is all about increasing exposure. So in the past, instead of just asking a more traditional stoichiometry problem, I might ask them something like this, where I give them two options for what a chemical equation could be. And I give them the necessary data. I give them a guiding question just saying, well, look, based on this data, what's the balanced chemical equation for the reaction between copper and nitric acid? And the way in which they're going to need to do this is, yes, they'll need to do stoichiometry, but they're going to need to actually generate an argument in the form of claim, evidence, and reasoning. So they're not only engaging in the stoichiometry itself, the content matter, but they're also engaging in the process of argumentation. Really convince me which of these two options is the most correct. And I like this because it's really trying to bridge that gap between the content stuff that we're trying to get them to understand and the communication skills and the lab experiences and the analysis, the science practices that we're trying to get them to merge together in a cohesive manner. And another kind of less scary way for students is to just use this more often, say on Google Forms, where you just give them some statistics on things and random data sets just to simply practice CER. And so I like to do this with, maybe once or twice a week. They can be science or non-science examples, and just asking a simple question and then asking them for their claim, their evidence, and their reasoning. And we kind of look at these together as a class and just maybe spend 5 to 10 minutes talking about what are some valid claims here, what is some valid examples of evidence. Just exposure is the main goal here. One of my favorite ways to do it is use throughout a demo. So I give students the reaction itself, and I give them the heat of formation values for each of the substances involved. And instead of asking them just something like calculate delta H, to say, look, I want you to come up with an argument that provides an explanation for why this glass stuck to this piece of wood. And so why do you think that happened? And so they end up actually providing some kind of claim as to why it stuck, using their evidence that is supporting that claim, and then going deep into the reasoning. And that is really communicating to me the extent to which they understand, say, the difference between endothermic versus exothermic reactions. After doing this for a while, I started to notice some of the really positive effects of this. And so this guiding question that you see up top is actually very similar to one of the exam questions that I showed you earlier. And you can see here that they give me a claim and they provide evidence, but the reasoning, again, is the heart of this. And I really like getting my students to try and understand that they should be starting off with some kind of foundational piece that is really going to help drive their reasoning. And so saying each element has its own unique chemical properties that can be used to identify its presence, right? So saying that alone is establishing the basically the foundation for what's going to come next, right? This is communicating a lot more useful, deeper information to me that is really allowing me to evaluate the extent to which they understand the material. As a teacher, I'm also really convinced that this particular student, or this group of students who wrote the CER on their whiteboard, understands not only what took place in the lab, but they understand what is taking place in the related to the content, and bridging those two things together. And so if you're thinking about doing this, one thing I would strongly encourage you to do is sit down with your colleagues and develop some kind of CER grading rubric together. Now, there's not a one-size-fits-all, and chances are that whatever you were to come up with is going to be somewhat similar to what I would or what another teacher would. And I have two examples right here, and you can see the ways in which we've chosen to score it may differ, but much of what we're talking about as far as evaluating our claim and evaluating the evidence and the reasoning, there's a lot of similarities to it. And one of the things that we've chosen to do at my school, at least, is really make this process of engaging in evidence-based arguments through written claim evidence reasoning is actually evaluating it and assessing it as a scientific skill. And this skill is pretty simple. It's just I can construct an evidence-based argument. But you can see the components for it are specific to claim, evidence, and reasoning. And so this skill that we're evaluating, this standard, so to speak, is being continuously evaluated but updated throughout the year. And it's allowing us to see how is this skill developing over time. A couple of the resources that I just wanted to share with people that have helped me along the way. Argument-driven inquiry in chemistry, though it's not specifically geared toward just looking at how to write better science explanations. It's serving a much larger purpose than that. Another book is Ambitious Science Teaching, and again, it covers a lot of ground that's not just specific to getting kids to be better explainers of things, but it's one of the features that they do go into that I have found has helped a lot. And as far as an online resource, this is something that not only Catherine McNeil is involved in, that I mentioned earlier, that really inspired me to get into claim evidence reasoning, but the Instructional Leadership for Science Practices. And so that is a website that seems to be dedicated to trying to help teachers integrate a lot of the NGSS practices into their classrooms. And you can find clarification on a lot of different things for what exactly teachers are trying to look for when asking students to come up with evidence-based arguments. So anyways, I hope that was helpful. Thank you for tuning in. And as always, feel free to let me know if you have any questions. See ya.